Hello, welcome to transformations of linear and absolute value functions. So every single function we deal with is going to have to be transformed in some way, shape, or form. It's normally up, down, left, right, stretch, shrink, and reflections. So all that means is that you're taking the graph, and instead of it being at your parent function, you're going to move it. So that's to the right, and it's a reflection because it goes from top to bottom. So it can move multiple times, it can move once, it can move 5 times if you need it to, but we have to be able to recognize how it's going to move based on the equation, or write an equation based on the transformation. So in order to know how to do that, let's fill in this chart. Now, whenever you have a parent function, you can always look at the parentheses. So we think of this column on the right, because that's the basic function. That's no matter what function you plug in, f of x is your parentheses, or it's your absolute value bars. Okay, so if it's inside of that, it's inside the absolute value. So notice how this equation is only different from this equation because this has an absolute value of x and this has an f of x. The function is the absolute value. So even if you didn't get that, let's go through the transformations. Now, if it's outside, it's vertical. If it's inside, it's horizontal. So let's say it's outside, right? This k, that k in blue, is outside of the f of x. So it's vertical. So it's either going up or down. Now because it's positive, it's going to go up, and then when it's negative, so when it's minus like this, it's going to go down. So there's a vertical translation, up or down, because it's outside. The k is outside. It's being added to the end. Now, if it's inside, so here the h is inside of the parentheses, and let's just circle the h. The x is always there. Inside. I have this acronym. It's called I high. If it's inside, it is now a horizontal change, so either left or right, and you do the inverse of the sign. So, since this is a plus h right here, it's actually, we should be going to the left, the inverse of what you think it should be going. And it's horizontal, so our options are either left or right. So we're going to move left because it's inside and it's horizontal, but we do the inverse. The same idea applies for this negative h inside. It's inside, so we do the inverse, and it's a horizontal change because of the I high. So instead of thinking negative h left, you have to think negative h to the right because you're doing the inverse. So we're going to go right. Now if the number is out front, it's either a stretch or a shrink. So this is in front, it's outside. So we're not going to do the inverse. We don't have to worry about that yet. If it's greater than 1, so if it's a big number, a number greater than 1, and it could be a fraction greater than 1, it is a stretch. If it's less than 1 and greater than 0, so if it's a fraction between 0 and 1, okay, or a decimal, that could be 0.25. It just can't be negative. Negatives don't count here. Then we have a shrink. Now, on this next one, we have horizontal. Horizontal is inside. And if you look, the A, which is what we're dealing with, is inside. Well, anytime you have something inside, you do the inverse. Inside inverse, inside horizontal inverse. So we have to do the opposite of what you would think. Okay, so instead of a stretch, when A is greater than 1, we have a shrink. And instead of a shrink, when A is between 0 and 1, we have a stretch. So we're going to invert our way of thinking. Now, we have reflections. This negative is outside. That means we have a reflection in the x-axis. Now the x-axis is right here. So that means instead of going up, we're going to go down. That is a vertical reflection. That's why it's outside, because we're going from top to bottom. Now I have to add something in here that was missing. We need a reflection in the y-axis. That means, I'm going to draw this over here, that instead of being over here, we're going to flip over that y-axis and go over here. So that's a horizontal change. That's going from left to right. And that's going to look like y equals f of negative x. Or y equals inside negative x. Or y equals the absolute value of negative x inside. And then the last one is just everything put together. You could have any combination of the top, any of them. Like they could all be there. So, now that you've written those down and you know that inside is horizontal and you do the inverse, let's try this on a couple of equations. We're going to write an equation based on a verbal description of what's going on. So, example 1. Now, the absolute value bars weren't there, but I need you to write them in. So we're going to write a function g, so we need g of x, whose graph is a translation 5 units up of the graph of f. So we have the graph of f is the absolute value of x. That means those are the symbols we're using. So go ahead and put a big absolute value with space, because we don't know where this 5 is going to go yet. Well, it's up. Up is vertical, which means it is not eye high. Well, that means it's not inside. It's outside. And it's vertical. So, we're not doing the inverse. Sorry. So we have plus 5 at the end. Now, if you were to look at your table, you would see, so let's go back to our table, that plus k is the up, because that's that first line. Up is a plus k on the outside. That supports exactly what we just did. Now that's the only description, so we're done. So if you wanted to condense that to make it closer together, you'd write g of x equals the absolute value of x plus 5. It didn't change anything, I just moved it closer. Alright, for b, we're writing a function h, so we need h of x, whose graph is a translation 1 unit to the right. Well, right, that is horizontal. So we have an eye high situation. Inside, horizontal, and inverse. So the horizontal is covered. It goes inside, which means that we have the x and the 1 both inside. Okay, that's taken care of. Now the inverse. So instead of 1 unit to the right, we're thinking negative to go left. So it's a minus. That's your answer. Let's continue. Write a function k whose graph is a reflection in the x-axis. So we have k of x. Now if you go back to that first page, to the front of this page, you know that reflection in the x-axis is a negative absolute x. Stretches and shrinks. These are a little bit different. We need a function g of x whose graph is a horizontal stretch by a factor of 5. Horizontal stretches. Well, that is an eye high because it's horizontal. Okay? Horizontal, horizontal. That means it goes inside. Now, stretches and shrinks go out front. So we actually need the absolute value of x with space in front, inside. So we've covered the inside, but we do the inverse. So instead of writing 5, because it's multiplication, the inverse of multiplication is division. Okay, the inverse of addition is subtraction. The inverse of multiplication is division. That means we need to put a 1 over our number. So it's no longer a 5, it is a 1/5. Okay, that's what makes it a stretch, because you take that number and you flip it. Let's try that again. Almost, right? We're going to do B. So we have H, and it's a vertical shrink by a factor of 0.25. Well, 0.25 is the same as 1/4. Now, because it's vertical, the I high does not apply. So it's not inside, it's outside. And we don't do the inverse, we leave it alone. That's why it just stays 1/4. Now let's do multiple things at a time. Okay, so we have H. So what I'm going to do is what I started with. I'm going to just leave blank space with an X inside because we don't know where things are going to be. So we have a horizontal stretch by a factor of 8. That's an I high. It's horizontal. That means it needs to be inside and the inverse. Well, the inverse of 8, if it's inside and in the front because it's a stretch, is 1/8. And it goes inside because of this. So we've got that covered. And then we have a translation 10 units down. Well, down is a vertical change. So again, so this is not an I high. Well, if it's not inside, it goes outside. And if it's not inverse, it stays minus 10. So to write this closer together, you would write h of x is the absolute value of 1/8 x minus 10. That's your answer. Let's do one more. We're going to write a function p, so we need p of x. And we've got a lot going on, so we're going to have that blank. Horizontal shrink by a factor of 0.5. Well, 0.5 is the same as 1/2, but this is an I high. So it goes inside, which means it's going to take this spot right here. But, so we've got that covered, but we do the inverse. The inverse of 1/2 is not 1/2, it is 2. So we're going to take the 2 and put it right there, because we have to flip it. Then, we have a reflection in the x-axis. Well, a reflection in the x-axis, that's your vertical reflection, so it's going to go outside, so we have a negative. And that's it. So p of x is negative absolute 2x. And we're done.